Good morning, good afternoon, good evening to people around the world. This is Martin Hubel, your host of the Db2Night show. This is show number 238 just for Db2LUW. That doesn't even count 119 or 120 shows we have done for Db2 ZOS. So we continue to go along, and appreciate having a very dear friend of mine on the show with me today, Phil Nelson. How are you doing, Phil?
I'm fine, thank you. It's a lovely sunny day here in Scotland, so therefore the weather is great, so we're all feeling good.
Yeah, the funny thing over here is our temperatures have been quite high. We're around 20 degrees, 22 degrees Celsius, which is about 72 Fahrenheit, which is rather unusual for October. But when it comes to Toronto weather, we will take it. We'll always take good weather. And
yeah, well, we got our first frost overnight, so.
We have not seen that yet. We normally have frost even by the end of September, at least one to give you a grim reminder of what is coming. We have not had any frost, and the weather was so pleasant. A good friend of mine nearby plays trumpet, and I had my trombone. We were out on my front walkway playing duets for our neighbors, and we have a rather eclectic bit of music from Herb Albert to whatever, so we had a lot of fun. Anyway, back to the show at hand here. And we'll be hearing about lessons learned with building Db2 HADR clusters on Amazon Web Services. So this will be interesting as Db2 expands into the virtual platform, so to speak. And so let me get the housekeeping out of the way so we can get on to the show. As always, here's our Get Involved social media page. And here's our trademarks. Everything's recorded. We respect trademarks. Have a nice day. I remember those days when I used to try to read that down quickly. Just leave it up for a minute as we talk about it. But those days are long past. So the other quick announcements we have, the fall schedule through December is filling out. I also have another date for Db2 on Z in January. I just got to remember who it was that I promised that slot to. We've even got, I put it a large appeal for speakers for October. For some reason, I just wasn't having any luck. And Phil graciously and well overdue has filled in for this month. We've got Jim D of BMC next week. And then we've got other well-known and good friends, along with some new speakers. We've got a couple of IBM product managers on Blue Runtime and Compression next month for Db2LUW. Satya will be speaking, and in December we have Soumya speaking as well, and she will be speaking on Datagate. So there's all sorts of really cool stuff coming up. As always, DBI Software is the host and primary and founding sponsor of the Db2Night show. And as always, if you need to learn more about their products, there's the link to do that. And if you do that, you get an Amazon gift card, as I recall, or at least a Starbucks card or some other small token for your participation. And our winner is of last week's show is Chuck Cozen of AAA California. Congratulations, Chuck. It's always great. You and your staff are loyal supporters of the Db2Night show, and we appreciate you doing that. And our sponsors, DBI and yours truly, Martin Hubel Consulting, Inc. And that takes us through that. And now we're into our little polls. Let me find the polls. We don't have too many today. That's okay. We still like to have people participate. So our first poll is, as always, what versions of Db2 are you running? So the poll is in progress. Find out where people are. And I think we'll close this off. A number of people have voted, and we're still getting votes, and I'm going to wait. 3, 2, 1, close, share, and there we are. We have an awful lot of different versions of DB2 being run. That's great. Mostly new, which is better. I'll hide that and move on to our next poll is which operating system? We haven't asked this question for a little while. It's always a bit of fun to hear this one. See, we used to have quite a few AIX people, but these days we seem to be more on getting Linux folks. I let people have multiple votes here just to see what platforms are being touched. You've got, when I said other Linux, I mean things like Ubuntu and anything else that people can come up with, or CentOS, or some people like to say CentOS. It's really interesting how you get into these discussions on how to say an acronym. And that varies actually as you go around the world. And here we have pretty strong indication that Linux is coming along. It's nice to see some Windows people there. I still run Windows, DB2 on Windows in my home office here if I'm running it for myself. And when I'm teaching, it's always good to have that. I taught a class on DB2 system performance last month for people scattered around the world from one company. Gosh golly, I tell you, the one thing with COVID, and actually as the world economy goes where it's going, we have more and more people in various places. It's interesting when you're talking to somebody about the weather and it's in Barcelona or Buenos Aires or someplace like that. That's fascinating. And what platforms, native install, or if they have some of the other cloud services. There's been a great deal of talk about the cloud services, and I'm sure they'll come to you at some point, but as it stands right now, there's still a lot of people that just like to have it on their own machine without the small overhead that comes along with being virtual, with the virtualization. So we'll have a look at that. And surprise, surprise of our audience today, we have 100% native installs. Interesting. What's that tell you, Phil?
It doesn't surprise me. Despite all the effort, the vast majority of people still want it on their own hardware, and well, we'll talk a little bit about some of the reasons in a little minute or two, I suspect.
Yes, it always seems to be the way, doesn't it? And I must say, I'm when it comes to that, I'm kind of traditional myself. All right, and so that takes us to Phil. You can take over now. I'll give you. I will make you commander of the screen here. I'll make you the presenter right now.
Okay.
You should have a message on your screen, and as soon as you click on that, we'll see yours. And there we go.
Yep.
We do.
That's fine. Let me just get this going.
Yep.
There we are. Hopefully I'm not showing anything at the side with the controls or anything. Hopefully that goes away.
Show up. The controls are yours and yours alone, and that looks just
fine. That's fine.
I'll mute myself just to keep from disturbing you, but I'll watch the question and answer queue, and I'll break in with any questions at any time. If you need something from me, just give a holler, and I'll be here as well.
Okay, that's great. Thanks, Martin. Okay, so thanks everybody for joining us today. Hopefully everybody can understand my accent. It's not every day you have to listen to someone from Scotland, and we tend to speak very fast, as Martin sometimes tells me. I need to repeat that because sometimes I'm undecipherable, but we shall do our best.
Well, there's also the Scottish speak as opposed to what we consider Canadian speak. When I told him about my system being out of date, that I had shoemaker's children problems, and he said, "Oh, the cobbler's bairns."
The cobbler's bairns, that's the one.
That's
yeah,
it.
And also even in the DB2 land, since we have to make sure that we talk about DB2 for Z when we speak across there, and we have to call it CICS rather than KICS.
Yes.
But two countries separated by a common language.
Indeed.
Anyway, getting on with this, we'll go to a totally different country in the cloud somewhere for a little while. So what we're going to speak about is some lessons I've learned when building DB2 clusters on Amazon's cloud services, Amazon Web Services. So we'll hopefully not spend too much time on the first topic, which is an introduction to cloud technology, but just a little bit information about that, just to set the platform we're going to build on, and everybody is singing from the same hymn sheet, as it were. Then we'll talk about different ways you can run DB2 on the cloud platforms, not just Amazon, but a variety of cloud platforms these days. And then we're going to drill down into building database servers using the cloud, but only using it to provide you the infrastructure, IaaS infrastructure as a service. And why on earth, if you're going to the cloud, why would you then want to roll your own DB2? And we'll take a little bit look at that. And then to round off, as I've looked into this and been working on this for quite some time, I learned some things about DB2 that I didn't know before I started working on Amazon Cloud. And then to finish, we'll speak a little bit about things you learn about Amazon and other cloud providers that maybe you didn't know until you started running DB2 in it. And being a true Scotsman, some of these lessons I learned affected my pocket. So I think they're important because you don't want to spend money needlessly. So that's the agenda for today, and hopefully everybody will find something of interest, and maybe we'll learn something along the way. I certainly did as I was going through this. So it's an often quoted adage that cloud computing is just somebody else's computer. And in some ways that's true, but there's a bit more to it than that, I think it's fair to say. So let's have a little look at some definitions and some information about cloud technology in general. So we're speaking at cloud services in general, so not just Amazon, but also the other big providers. So of course we've got IBM Cloud, but then we have probably what I would call the big three providers now: Amazon, Google, and Microsoft Azure. And essentially they all provide a number of different services, and I would split them into these four categories. And in fact, having just completed my Google Cloud Associate Cloud Engineer exam, and having studied for that, they do the same thing. They split it up into these four main categories. So the first is that they provide compute resources. They provide computers to run your applications on, to run whatever software you want, and they provide it in different flavors. They provide mostly Linux boxes, and different flavors of Linux, but if you want, you can also get, for example, Windows computers running on the cloud as well. So they provide compute resources that you can either install pieces yourself, or you can get pre-configured servers of one type or another that will run on these compute resources. The next thing that they all provide is different flavors of storage. So for example, you have the storage that you would attach, like disks to servers that are for, that you make file systems from, that you can then access individually like you would on your normal computer. But you can also have object storage, for example, where you can store files, but you can't read inside the file. You can either send it up to the cloud, or you can retrieve the file in its entirety. We'll speak a little bit about object storage in this session later on. Then the next thing they provide is a wide range of networking capabilities. Not only ability to create your virtual private networks that you can separate your cloud resources from other people and even from inside your own cloud accounts. But they also provide services, for example, like domain name services and a variety of other networking capabilities, capability to connect your cloud services up to your on-premises services through a number of different methods. And then the last thing, and this seems to be the growth area at the moment, is what I've called specialized services. So pre-built services to meet a particular need, often taking a bunch of software, configuring it for a particular purpose. And a lot of the focus in that area is actually in the artificial intelligence, machine learning, these kind of spaces. But you'll also find that there are pre-configured web servers, database servers, both from vendors that you would normally think of as on-premise database vendors like IBM and Oracle, Microsoft, but also the cloud providers are starting to develop their own database software that they provide through their cloud. But the compute resources are at the bottom of all this, and storage are the building blocks of bringing it all together to make these services. So a little bit more of some of these. So the compute resources, we talked a little bit about this before. So at the lowest level, you have virtual machines, which you can then configure and build as you like. Then they're starting to supply managed Kubernetes clusters and Docker environments. And of course, some are further on in that journey than others. Google is very much into providing Kubernetes because they are the originator of it. Also Docker environments for running Docker containers. And the last thing which may confuse people is they talk about serverless computing. And this doesn't mean that there are no servers involved, just that you don't have to configure them. And so they provide a service, and you call the service, and it could be anything as simple as tell me the time of day, to a variety of services where you provide a function to run, and the function gets run, and if they need to scale it up because you're getting it called lots of times, and you pay for the number of times you use that function being executed. Storage facilities. So as we said before, that starts off with object storage, which is for storing files, and probably the best known of these is Amazon's S3 Simple Storage Service that has buckets where you can dump files that you want to save. And most object storage now has different levels of availability. So for example, on Amazon, you have the standard S3 storage, but you also have a type of storage that is used for much longer storage and less frequently accessed and costs less until you want to take it out. Then you have file storage, which is a bit like the NFS, and most of them use the NFS protocol, where you have a file system that can be mounted on multiple servers at one time. And we'll speak a little bit about how we use that in the Db2 space in a minute or two. Then block storage is like the disks that we format into file systems and mount on servers. So if we're creating databases and we want to have our data on separate disks, it's block storage you're using. And the last thing that they often provide is a memory cache system where you can put data in memory and have it highly available. Not really something that we would use as Db2 people, but if you want to dump stuff into memory for really quick access for certain things, then that's available on most of the cloud providers. So networking, we spoke again about, internal private networks between cloud services, then linking up cloud services to the internet or to other external services. Then you can link up the cloud to your on-premise services privately so that there's a direct link and you don't have to go out over the public internet, and domain management services. And then some of the specialist services we talked about, normally to meet a particular business function, and many of them relate to machine learning, analytics, artificial intelligence, and there's often stuff like multimedia processing where you can process uploaded images, perhaps looking for people's faces or whatever the people want to do with nowadays to find out where people have been so they can tag them. These kind of things are all available as specialist services. So, skipping from the general onto running DB2 in the cloud, interesting that we had the poll about where do people run their DB2, and it was 100% for running on premise. So the other ways to run DB2 in the cloud, of course, first would be containerized, whether, well, IBM is very much in favor of Red Hat OpenShift, of course, because they own Red Hat, but there's talk going about other Kubernetes platforms, and even for a while there was some Docker images floating about. So that's one way to do it. The next way people run DB2 in the cloud is that IBM offers services, database as a service offerings, where IBM manages the database installation, and essentially what you're provided with is a database that you can then go in and create objects, create schemas and everything from there down. But as far as managing the infrastructure and managing, in fact, the DB2 install, IBM does that on your behalf. And there's two flavors of this. One that by default creates as a blue DB2, which is DB2 Warehouse and Cloud, and the other which is set up for online processing with row level, a row-based tables by default, and that's DB2 on Cloud. And the first of these is more mature than the second. In fact, in my day job in Lloyds Bank, we have DB2 Warehouse and Cloud that we've used as a part of our infrastructure, having replaced an existing Netezza appliance with DB2 Warehouse and Cloud. But the last one, and the one we're going to concentrate on, is infrastructure as a service, which I've called roll your own DB2 on the cloud. So essentially, you go to the bottom level of these resources that are available, whether it's networking, servers, storage, and you roll your own. And that's what we're going to spend most of our time talking about. So why on earth would we roll our own? Well, I was trying to find an old video of an advert that ran in the UK when I was probably when I was a teenager. And at that time, there was a lot of people were switching from the traditional gas hobs for cooking on to electric hobs. Of course, one of the things that, if you'll know if you have an electric hob, is that if you switch it off, it takes a while to cool down. And if you're boiling a pan, heating a pan of milk, by the time it cools down, it's flowed all over your wonderful, nice electric hob, and you've got to mop it all up. Whereas gas, you turn off the gas and the heat stops right away. And British Gas was running an advert all these years ago where they had a little man who eventually turned up his finger and a little flame came out the top of it. He said, "Isn't it good to be in control?" And that's basically the principal reason why people want to roll their own. They want to have as much control as possible. Many people are happy with the way a cloud provider will provide an operating system. They're also probably happy with the way that cloud providers provide disk storage and networks, but they want to put them together in a way which they feel is best for their DB2 installation, whether it's attaching a number of different disks so that they can spread their workload, or whether it's configuring the operating system exactly as they want it, or setting up the network between the cloud and locally, and also between different DB2 servers, for example, to build a cluster. They want flexibility in how they manage the server, and particularly in relation to when backups are run and when recoveries are run and how they're run. And certainly it's an area where, unless you're paying for the top level services, IBM, for example, on their services will back up the databases according to their schedule. And so we don't have total flexibility. And many people want that. Or it may be they want to configure a DB2 environment that just isn't available as a packaged offering yet in the way they would like it to be. So that's one way of doing it. But the other use case, which is often comes into play, is it's useful for learning or experimentation. It seems that in work I've done in my spare time, as it were, the larger the company you work for, the more difficult it seems to be to get servers to do anything. And in fact, a lot of what we're going to speak about today came out of such a situation where I was due to give a training course at a large American company where they wanted essentially to be trained in building fully automated Db2 HADR clusters, and they wanted the people on the course to be hands-on so that they would actually learn how to do it in reality rather than just hearing about it. But they didn't have the servers to provide to do this. And so part of what I had to do before I taught the course was to work out and test exactly how to build it on Amazon so that we wouldn't have any problems along the way. And it's just as well I did, because there's a few gotchas we'll speak about in doing that. The other great thing about cloud is that if you build it for a testing or experimentation, you don't have to go and buy yourself a large and expensive server. Once you're done with it, you just shut it down and it's gone and you're not paying for it anymore. And you can teach a week's training course with a whole bunch of people running their own clusters, and the bill is going to come out at what, $100 it cost me or something for the week for that, obviously for small servers. So you can hand it, and that's the big benefit of the cloud, is that you only use you only pay for what you're using. So lots of reasons why people might want to do this, both having control and also environments for learning, experimentation, testing. Also, if you build things in the cloud, you can run up extra servers if you need more workload quickly. It's a quick way of doing it. So, be that said, we're going to talk first about things I learned about Db2 while I'm setting up on Amazon AWS. And there's three things we're going to speak about in particular. The first is, do you know exactly which ports of all types are needed to run a fully automated Db2 cluster? The reason we ask this question is, of course, there are ones that maybe you don't notice if you get somebody to build a default build on premise or on your home computer. Some of these ports might actually be open by default. And we're going to talk a little bit about that. The next one we're going to dig into is, how can you exploit the cloud storage, especially cloud object storage? But we'll speak a little bit about using the other storage options, particularly the network attached storage that we spoke about a little minute ago. And the next question is, well, we know that Db2 runs on certain versions of Linux, but what about the other ones? Is it possible to get a Db2 cluster, especially if you're just doing it for training? Is it possible to use other versions of Linux other than the ones that most people would use? And by that, I'm probably meaning Red Hat Enterprise. Is it possible to do that even just for experimentation, save you some money? So let's dig into these things a little bit more. So one thing you'll find about cloud providers, and this is why it comes up when you're doing it on Amazon, is that they're very aware that that security and access to systems is people's first concern when they're going to cloud. So what you will find is that when you get a server on Amazon or any other cloud platform, it will have been hardened very, very well. In other words, if you were to install, for example, Red Hat off a DVD or off an image onto your computer at home or onto a server in your office, there are going to be ports open by default. And you're going to find that the firewall rules might not be as tied down as you think they might be. But what you can bet your bottom dollar is when you go onto the cloud, they have this thing pretty locked down, and it's almost like by default, if you want access, you're going to have to open the ports. And so we're starting at the top, and we'll start going down, and nearer the top are the ones that people will be aware of. But the further you get down, the less people are aware of it, and certainly I wasn't aware of some of these ports in use. And so this will hopefully help somebody who's wanting to try build these things themselves. So at the top, the Db2 standard port for connecting non-secure, the default, if you do an install, is 50,000, but it's configurable either if you want to move it for some reason, or if you've got another instance running on the box. So you can have other ports, but 50,000 is the default one. The second one, also configurable, is the SSL or TLS port, the secure port. And typically, a lot of people would use 50443, just because 443 is the HTTPS secure port. A lot of people thought, well, why not make it 5443? At least something will be easy to remember. But totally configurable again, and people might choose for a variety of reasons to move it. So these are the ports that you need to be available if you're going to be just running Db2 standalone. The next one, and it's pretty well known, is that you need a port for the 2 or more instances involved in an HADR cluster to be able to communicate with each other. And typically I've seen that people would start at something like 5 fives, and for each database in an instance would increase from there. So 55555, then 55557, and so on and so forth if they've got multiple databases. But again, totally configurable and fairly well known. But then we come to the ones that you need for TSA, and these are less well known and typically are things that, unless you've got a very zealous systems administrator, you probably will hit these for the first time when you come to do TSA on a cloud environment. So the first one there are a number of ports that TSA, Tivoli System Automation, uses by default. A 657 is used in both TCP and UDP mode, and then a couple of more UDP ports are also used, 12347 and 12348. And then last but not least, for the heartbeat between two servers, it does essentially is doing a ping, so you also need to allow ICMP traffic between the two. So these are the ports that typically you're going to have to open if you want to run a TSA-MP cluster. I've only run TSA-MP. I've not yet started looking at the pacemaker, and I'm sure that pacemaker has a similar set of ports that you'd have to open for pacemaker. Next thing, and we'll dig into this a little bit, is use of Db2 and cloud object storage. So a little bit more detail about Amazon AWS S3 and how it can be used in DB2 to good effect. So S3 is SSS, Simple Storage Service, and it stores files as objects. You can either read or write them in their entirety. And they get arranged into buckets, which are unique across the whole of AWS. So when you want to create a bucket, if somebody else has called a bucket with the same name, then you'll not be able to create it in AWS. So typically people would use, for example, their domain name as the first bit of a bucket name to ensure some form of uniqueness, or they would come up with some naming standard that would hopefully allow them to have unique buckets. When I say they're unique across AWS, it doesn't mean that everybody can see your bucket, but they can be public, or they can, or more generally, they're private. Just be careful if you're setting these up to store all your DB2 backups that you don't check the box or put the wrong option and make it public. And then they can be encrypted or unencrypted, but the default is encrypted. And the thing we need to be aware about these is that it doesn't cost you anything to upload data into it. You pay for the storage you're using, and if you're operating, I want to download the data from there outside the region that you've currently stored them in, you pay to download the data as well. And we'll speak a bit about that later on, how that can be a bit of a shock to the system if you think it's a good idea to back up your databases to AWS S3 and then end up restoring from it many, many times onto on-premise or somewhere on a different region. So 3 things you need to do. First thing you need to do is provide a PKCS encrypted key store, which is, I'll speak about these in a minute. Then you've got to define what's called a storage access alias. And then we'll show you some examples of how to use that storage access alias within DB2 with DB2 utility specifically. So first thing you've got to do is you've got to provide a PKCS encrypted key store. And actually, if you've set up DB2 native encryption, you really don't have to do anything, because it will actually use the same key store as the one used for DB2 native encryption. But if you're not yet at DB2 native encryption, I would probably ask, if not, why not? Because it's both easy to set up and also works very well. If you've not done that, then you need to know the incantations to set up the key store using GSKit. And this is this incantation here is how to set up that key store with a strong password and the name. Typically, people would create these under Db2-inst1 under a directory called security. One thing to be aware of is don't create them under Db2-inst1 SQL lib security, because with the exception of your user profile file, IBM reserves the right to do whatever it wants under SQL lib, and you wouldn't want to find your key store disappears. The other thing to be aware of is that this key store is not backed up by default by anybody, and if you lose that and you're using it for native encryption, then essentially you've lost access to your database totally. So once you've created it, make sure you back it up. After you've generated it here, you update the database manager, the instance, to tell it where to find it and the type it is, and then you stop and start your DB2 and it's available. What's going to be stored in this, as far as the S3 access is concerned, are the 2 pieces of information that are used to access Amazon S3. What Amazon calls an access key ID, and actually is found in the DB2 documentation, is a storage user ID, and what Amazon calls a secret access key ID, which DB2 documentation calls a storage password. These 2 items will be stored in this. If you try to configure the storage access alias, which we're talking about now, and you don't actually have that key store in place, it will fail because you don't have the key store. So this is a little copy from the manual about the defining a storage access alias. We'll have some examples in a minute. So it's a catalog command to use, the same as you would use catalog, catalogs TCP/IP node or catalog database. So we say catalog storage access alias, you give it a name, you say the vendor name S3, and nowadays even if you're configuring this from IBM Cloud, the default is to use Amazon S3 because IBM Cloud now uses the Amazon S3 protocol. In fact, most of the vendors are starting to use the Amazon S3 protocol as an industry standard almost definition. And then you can say default or you can say endpoint. We'll talk about this in a minute. And then the user ID and password of the Amazon credentials. And you can choose to stop at that point, or you can choose to add containers, or you can choose to add objects, and then you can specify controls over who can access this. That's the DB2 group and DB user. Let's look a little bit more detail at some of these things. So, because as you can probably gather when you're doing a catalog command, you catalog these at the instance level, so potentially available to any database. By default, they're only accessible by the sysadmin. If you see these DB group and DB user, these allow a group of non-sysadmin users or either a group or an individual user to access, and typically people would set up a group that's allowed to access these. The other thing that's worth noting is that the default region, if you don't specify it, and just specify default in that second line down there, is to go to US East 1 Virginia, which just happened, I think, to be the first or one of the first Amazon regions that was available. If you, like me, you're based in the UK or any of our friends listening in from Europe, this is probably not a very good choice because you really don't want to be putting your data into the US and break all sorts of GDPR regulations. So be aware where you're writing to. The container parameters allow you to specify buckets in a specific region. There's also another command called list storage access, which allows you to list any storage access aliases you've registered. And here's some examples of creating aliases, and you can create them at two levels. You can create an alias at bucket level and use the container to specify the bucket you want to go into. In this case, this is a bucket called scotdb.scotdb.eu, which would tell you that this is in the European Union. And the other command is the same, apart from it doesn't specify the container clause, and that creates at a region level. And in this case, it's creating it in this case, the S3 EU West 1 region, but not down to limiting things down to an individual container level. Now we'll see that whether you can do either, and it's going to have much the same effect, but it does have an impact on what you do at the next level down. So things you can do with Amazon S3, you can write output from backups, and you can write output from load copies as well. So anything that essentially writes a backup or a recovery, the other way around, or you can load data from S3 and you can export directly to S3, and you refer to them using, in the backup or the load or the export, you'd refer to them using a special syntax, which is like a URL that starts off as Db2 remote, and it gives the paths. You don't use the file name part of this. If you are doing a backup, you only specify the path. You don't give a file name because, of course, Db2 makes up its own file names. And you can see that if you use a bucket alias, you need to have a // and then the storage path. If you've defined a region alias, you have slash, then you give the bucket name, then another slash. So the slash slash in the first one is essentially telling you that the bucket name is already defined, so you don't need to go any further down. And then the storage path within the bucket. Some examples. So here we're backing up database, and we're backing up using the two definitions we had previously. The first one backing up to a bucket level. So we're backing up to the thing we called ScotDB.eu, which was a bucket level alias. Slash slash means we don't need to specify the bucket, then the directory within there called Db2 backups. Exactly the same thing would happen if we used this, where we've got this region level one, then we specify the bucket and then the backups. And here's an example of loading from a file called loaddata.xf, and it's from a bucket alias under a path called load files into a database. So some further notes about that. Be aware when you're doing this that a local staging directory is used, and this is the default, but there's an environment, a region environment variable you can use to change where that's used. So if you're not got a lot of space under temp, under SQL lib, you probably want to use this to route it to a place with more storage. And this seems to be getting lifted, but there was a limit of 5 gigabytes on S3 buckets, which they're starting to lift, but DB2 will split things up across. If you have a large database, we'll split it up into 5 gigabyte files. You should probably be aware of that. And of course, the bit that's missing from all this is the ability to archive logs. What I've said is a poor man's TSM or whatever would be great. And so I created an AHA idea for that, which is there. And recently it changed its status to future consideration. And there's been some social media from IBM saying that it's under construction. So I'm hopeful it'll appear shortly if it hasn't already. And I've not seen anything in the 11.5.7, which is due imminently and not in the beta stream, but it may well be there, and I've just not noticed it. So moving on a little bit to TSAMP. So as we know that this is being superseded by Pacemaker, but this is talking a little bit about TSAMP, some of the reasons why we're moving to Pacemaker, for example, is it's not being developed by Db2 team. The Db2 team wants more control, but as it stands, if you look in the Db2 install, you'll actually find RPMs, and you'll actually find Debian packages as well. You can't install them automatically, and the installation script can be very picky about which distributions you use. But these kind of things tend to be a challenge to me. So even though the TSE automatic install script doesn't work, I found you can actually install both the RPMs and the Debian packages manually, and so get them working on, for example, CentOS and Ubuntu. So the package is installed, but I've not configured full clusters, but it should be possible, certainly on CentOS, to get this going. Interesting, IBM ships these Debian packages which they've built, but never ever configures them anywhere. So moving on, some things I've learned about AWS, and I think I'm hopefully not going to run out of time here. So some of the things I've learned. So what's the scope for moving a virtual IP address? Something we do when we fail over a cluster in Db2. How can we make sure we run up a huge bill in a hybrid on-premise cloud environment if we're not careful? How do you set up different disks for Db2 data, logs, and backups? How do you share a disk between the two? And we'll talk about why we want to do this. And lastly, how do you automate cluster builds? So in this section, I'll basically say, why am I asking this question the first time? And then we'll look at some of the answers. So, scope for a virtual IP address. Why do you need a virtual IP address? Well, a fully automated HADR cluster will float a virtual IP address from the first server to the other server in the event of a failover. And during the TSAMP cluster, so Db2 Haiku, you have to define the IP address you want to use. And it's moved during a failover, planned or unplanned. That's not a Scottish word, planned or unplanned. It's actually just a typo. So some of the things you can do: automated client routine rerouting for current active connections. If you don't want to use a virtual IP address, these are some of the alternatives. You can use the update alternate server to specify another place to go. You can use JDBC client configuration to specify alternate server names, or if you're doing non-JDBC, you can add an alternate serverless stanza in your db2ds driver config file, and there's other parameters for that. Or you can actually just choose to change your DNS manually, which will take a long while to do, and there are services, for example, in AWS to monitor hosts and then change DNS using their Route 53 DNS service. But there is, a limited scope for using virtual IP addresses, because inside AWS, virtual IPs are basically private to the region area. Other cloud providers actually are a bit more flexible in this. For example, Google Cloud offers you to create virtual regions that span the globe. So that's maybe something, if you're looking to do this kind of thing, then there's always the possibility other cloud providers vary in what they provide. Next thing, why do we need to be aware of costs? Well, wrong decisions can cost you an awful lot of money that you didn't expect. And some of the biggest costs are not in the most obvious places. And if you're operating in a hybrid environment, part cloud, part on-premise, risks of incurring costs increase, but it doesn't need to be necessarily hybrid cloud. If you're operating across multiple AWS regions, you could also incur costs when you didn't expect it. So here's a little bit summary of how Amazon charges particularly for data transfers. So if you transfer data into Amazon, free, apart from you pay for the storage. If you transfer between AWS regions, it costs money. If you transfer data out of AWS, it costs more money. And that's the basic principle. So things you would probably want to avoid doing is storing your backups from an on-premise server in Amazon S3, and then using it, for example, in an automated test build pipeline to restore a database every time you run a test. That would get very expensive very quickly. Typically, I discovered that to restore one backup would cost approximately the same amount as storing that backup in Amazon for a month. So, something to be aware of. A HADR log shipping between Amazon regions or on-premise, from Amazon to on-premise, would be costly. If you log ship from on-premise to Amazon, much cheaper. But be careful in that case. If you fail over, for example, from on-premise to the cloud, remember that bringing back up your on-premise server will start to ship logs back to on-premise, which will start to cost you money. Loading data from S3 to on-premise or to another region, if you want to load data from S3, upload it to S3 buckets in the same region as where you want to load. And the other thing is, if you have high volume application servers, don't really try to run them on premise while having your database servers in AWS. In other words, co-location is king until, of course, you come to a recoverability. So you need to think about that, but be aware that if you're not co-locating everything in the same Amazon region, there are going to be costs involved. The other one, which might surprise people, is most things in Amazon are free if you shut them down. So if you build a server and you shut it down, you're only paying for the storage, unless you've defined an elastic IP address, which is an IP address that allows you to keep a static IP available for use on the internet, essentially. And since these are limited, a limited resource, Amazon encourages good practice by, if you shut down and are not using an elastic IP address, you're going to pay for it while it's not being used. And that's a non-obvious way to incur cost. So only define them if you're using a public-facing IP address, and there are other better ways of exposing public addresses rather than directly with elastic IPs. There's Amazon networking capabilities to allow you to do that. So why would you want to use separate disks? Well, when you run up a server in Amazon, you get one disk and everything's on that disk. Of course, most of us would prefer to have more disks for a number of reasons: resilience, performance, using the best storage for what needs the best storage, and using cheaper storage for less frequently accessed data or where that's not required. And also, if you want to add storage easily, it's better to have separate disks you can work on, or you could even take snapshots of disks in certain circumstances to clone systems. So this is a typical layout I would probably set up for a small Db2 server with 4 data areas, primary and secondary logging area, a place to install your Db2 software, and then an area for your Db2 home directory and a place for putting backups. As I said, by default, you get one disk, which is called dev.sda. You can resize it, but if you actually are adding multiple disks, often you might want to reduce that. And you would add it, if you're using the console, Amazon console, add volume to add each required disk. The disk device name gets allocated automatically. You just set the size, launch the instance with the disks attached. Add volume, you do this when you're actually creating the server or defining the server. And then check the disks are available for use, and that's the command to list all the disks that are available. And then you have to go through and prepare file systems yourself for each of these disks. Then you want to create mount points for them all and mount all the disks, and then make sure you back up your file system table, and then add all the records to the file system table to get it active. Make sure that FS table is actually correct. So don't leave until you're able to do the amount -A, reading the FS tab. It works. If that doesn't work, restore the old one and put it back. If you leave and this doesn't work, you're probably unlikely ever to boot that server properly again. Some further notes. It's easy to resize volumes. You can either do it offline, or now there's some of the changes to volumes can be done online in Amazon. And other changes are easy. So, for example, if you build a server and you find that there's either not enough resources or there's too much resources, you can actually shut down the server, change the size of server in Amazon to a different t-shirt size, and start it up again. And instantly you're running with more or less resources, assuming you have the license that allows you to do that. The next thing is sharing disks between virtual machines. And why would you want to do this? Well, if you're not using something like Spectrum Protect or TSM with shared aliases, you actually need to provide a place where both servers and HADR pair can access particularly load copy datasets. If you don't do this, and the standby can't access any load copy you take, then your HADR will fail. So you basically want to be able to have a shared disk area where your backup files or your load copy files get written to if you're not using S3 for your storage. So Amazon uses Elastic File Storage to do this, which uses NFS protocols. And for sake of time, I'm not going to read this out, but that's the details about how to set up a Db2 BCK11 disk, which is uses EFS. The next thing is, why would you want to automate cluster builds? Well, we're doing this stuff manually, and setting up a server, even if you're clicking through the Amazon console or lots of keystrokes using the Amazon API, well, lots of clicks, easy to miss something, just time consuming. As we know, Db2 has got lots of means of automating, so Db2 setup by SR for response files, a number of Db2 command line tools for running SQL commands, and Db2 Haiku with a config file to set up your cluster. AWS supplies a build automation tool called CloudFormation and takes in a number of formats. There's a graphical tool that you can use to help you to do it. It allows you to parameterize pieces. And actually, there's quite a decent blog that shows you how to use CloudFormation to build a Db2 server here with some provisos. It uses Db2 11.1 currently. It installs on top of Windows servers for some reason, even though most people, as we saw, are not using Windows but Linux. And it's not necessarily using all the best practices for either Db2 or AWS. So some of us maybe need to volunteer to get together to do a version 2 of this that works slightly better. So that's all I had, Martin. Hopefully we've learned something.
That's great. And I've noticed that you've done such a great job of explaining things that we have no questions.
That's either that or people are just kind of like, what on earth was that guy talking about? Or was that English?
No, it's none of that. Let me take control back from you so I can I can show my screen here and do the final most important polling question of all, which is let me move that on and come over here. And did you learn anything today? This is always an important question. Yeah. And as expected, we have good news on what people learned or how many people.
That's good.
And 100% is always a wonderful thing to see, and it's an indication of just how valuable your session was today. So,
okay, well, it's better than last time because I dug into. I thought I had done a session on the night show before, and so I actually found it in my Dropbox, and when I went for a search, I found that it was January the 18th, 2014, and it was a Z topic.
Yes.
So if it was as good then as I was, and I was 92% of people learned something that time, so I've improved.
That's right. And sorry to have you back on.
That's no problem. I've been too busy doing other things, I think. So
indeed, you have. Yes, we often have a busy Phil. That's for sure.
Yeah, but it's been great to be here, and hopefully everybody enjoyed it, and I'm sure that
they did. They wouldn't have given you 100%. So anyway, let me cue the music and get people off to lunch here.
Okay.
And I just need to turn the volume up so people can actually hear the music. There we go. I hope everybody has a great weekend. And if you're a Z person, you can come back and join us next week for Jim D of BMC, building blocks of Db2. We'll look forward to seeing you then. Thanks again for your support of the Db2Night show, and we'll see you next time. All the best. Bye-bye. Thanks, Bill.
Thanks, Dave.